Hello, everyone. It's nice to see the number of attendees growing here. I'm gonna wait like 1 more minute until everybody's able to get to the room, and then we get started.
Sounds good. Thanks. I see a lot of names I recognize here. Hello, everyone.
That's nice. Yeah, we have some very loyal attendees here at the Antarctic lecture, people that they are here for every event.
Awesome.
Really nice. All right, I think we can go ahead and get started. Good evening, everyone. My name is Andre Franco. You all know me, the ones that attend lectures in the past years. On behalf of the School of Global Environmental Sustainability here at CSU, I want to thank you all for attending tonight's Antarctic lecture. And before we start, I want to remind you all, or to just let you know that this event is going to be recorded, and the recording will probably be available at the YouTube channel for the Poudre River Public Libraries in a couple of days. Usually it takes a day actually for them to do that. So very soon you'll be able to look for that. Once we start the talk, please submit your questions through the Q&A button. Don't use the chat. It's much easier to follow the questions in the Q&A button. So you can send your questions at any moment during the talk, but we are going to address all of them at the end, okay? So we are very happy today to have Krista Myers joining us from Louisiana State University. Krista is a researcher and lead field technician for the McMurdo LTER meteorology and limnology team. She holds a bachelor's degree in Earth and Planetary Science from the University of California, Santa Cruz, and a master's in geology and geophysics from Louisiana State University. Krista has been to Antarctica 6 times, so she's a veteran, and was chosen as an early career expert reviewer for the most recent IPCC report, which we discussed a little bit in the previous event. So in 2022, she was appointed by the mayor of Santa Cruz, California, to serve on the city's Climate Action Task Force, where she will help shape the climate action plan in her community, as she's been done already for the McMurdo LTER. So Krista, we are very happy to have you tonight. Please go ahead and start your talk. Let me just make sure I'm recording this. Yes, I am. So yeah, the floor is yours.
Okay, thank you so much, Andre. Can you hear me?
Yes.
Okay, cool. Well, thanks everybody. Thanks for being here, and thanks to CSU for inviting me. I'm really excited to give this talk today. It's a little different from most talks that I give, in that I'm going to be talking about collecting climate data in Antarctica while addressing its carbon footprint. So I actually didn't get into Antarctic research right away. I was very obsessed with astronomy growing up, actually. So I just wanted to learn everything I could about space and stars and the planets. And as I was an astrophysics major in college, I started to take some earth science classes and took a few field geology courses and was pretty much hooked, and realized that, you know, out of all the planets that I was learning about, all these sort of unique exoplanets and everything, and all the planets in our solar system, once you kind of look at everything that there is out there and the billions of stars that we know of and all those planets surrounding them, Earth is really by far the coolest planet there is. So I was converted back to being on Earth, instead of trying to just focus on space. So then I kind of switched gears and started learning about the cryosphere, which is just a fancy word for like the frozen places on our planet. So I got into Antarctic research as an undergrad, and now I go down to Antarctica as part of my job. But just beyond just studying Antarctica, I realized quickly that I wanted to actually do something to protect it. So the cryosphere and places like Antarctica we can really see the impacts that humans have had on our planet with climate change. And it's pretty drastic. If you've seen Chasing Ice or really any good documentary that shows how much glaciers have changed over the last few decades. So I decided to really focus my career on that. And then more recently, focusing on what we can do to actually combat climate change and focusing on what I can do in my own job as a researcher to do that. So the goals of today's talk, other than just kind of telling you a little bit about my job as a researcher, I also want you to think of ways that, I'm going to be talking about how I'm trying to make my job more sustainable, but I want you to start thinking about maybe how you can apply this kind of mindset and think about how you can make your own job more sustainable and make change, and also to connect with other scientists and labs and to share ideas. So if any of this resonates to you, if you're a scientist and you're interested in trying to make your lab or your field site or anything more sustainable, definitely shoot me an email, because I hope that this is just kind of the beginning of something. So, okay, so this is our field site. This is a picture of Taylor Valley. So as Andre said, I work for the McMurdo Long-Term Ecological Research Project, the LTER. And the LTER has 28 sites. It's funded by the NSF, the National Science Foundation. And you can see here most of the sites. Can you see my mouse, by the way, Andre, if I do this?
Yes, we can see.
Okay. So you can see that most of the sites are in North America, but we have a few up in Alaska, up here. And then we have this one down here in the very bottom left corner, and that is our field site. That's the McMurdo Dry Valleys. So you're looking at a photo here that I took this past season. We have some glaciers here flowing in from the mountains. We have a series of frozen lakes at the valley bottom. We're pretty close to the coast, so you can see this is actually the McMurdo Sound here. That's the ocean that's has some sea ice in it. And you can see on this map that we're in East Antarctica on the coast, and we have this really special ice-free region called the Dry Valleys. So if you're thinking to yourself, that is definitely not how I pictured Antarctica. I guess there's quite a few people who are veterans to this lecture series, but and if so, you've probably seen this picture and you know that 98% of Antarctica is covered in ice and snow. So there's 2% of Antarctica that is actually ice-free. And I'm lucky enough to study one of a site in the 2%, the Dry Valleys. So it's a pretty, Antarctica is huge too. If you can see, it's 1.5 times the size of the United States. And so I feel very lucky to get to go to this tiny sliver of the Dry Valleys. So it shouldn't be a surprise to hear that the previous season was canceled, the 2020-2021 season. So because of COVID, classic. So we did not go down to Antarctica that season. So we had a year off. It was actually kind of nice. We got to have Thanksgiving and Christmas with our families and stuff. But lucky for us though, we had sensors deployed, these stations like the one that you see here that I'm going to be talking about. We had climate stations that were still monitoring, still collecting data. So even though the field season was canceled, science still continued, although limited. But we were very excited to get down this past season. We deployed from October of 2021 all the way through the end of February of 2022. So some people had, I think it was like 5-month field season. I was down there for 4 months. It was the longest field season I had ever had. So I'm going to be telling you about this most recent one. So usually when I give these talks, I show this slide about how to get to Antarctica, and it's just 3 flights. And you're there a few days, maybe takes a few days to go to New Zealand and get your stuff, but pretty straightforward. But this talk is COVID edition. So before you even leave the tarmac, you're already in quarantine. I drove from my home in Santa Cruz, California, where I live, up to the San Francisco International Airport. And that's where our whole team started our quarantine process. We had 4 days and 3 nights at a hotel at the SFO airport. Pretty nice. You can see here we have the bay in the background. I have a pretty good view actually. So we had a rapid COVID test upon arrival, then a PCR test the day before we flew. So just hanging out in SFO, and assuming that you tested negative, Then the next leg is going from SFO to New Zealand. So this is our crew. This is on, I think, yeah, day 4. So after everyone received negative tests, this was the first time we were all together in the same room because we had all been in our respective hotel rooms. And you can't go and interact with anyone. And then you can go outside for exercise along a sort of a lap around the building. But anyways, this is us getting ready to board our plane. We're all very excited. So this year was different because the United States Antarctic Program chartered a private flight from SFO all the way to New Zealand with all of the USAP participants for that cohort. So it was like 150 people or something like that. And the only people on our plane were going to Antarctica. And before you think it's like a fancy, jet plane, it was just a normal Boeing plane. But anyways, so once we got to Christchurch, we started what's called Managed Isolation and Quarantine, MIQ, and this is mandated by the New Zealand government. And that was 2 full weeks in a hotel room. We got tested, we had PCR tests like 5 times. Nurses would come by and test you every few days. And assuming you got a negative test, you stayed there and kept trekking until day 14. If you're wondering what it looks like inside the hotel room, this was my hotel room. You were just randomly assigned a room. I happened to get confirmed the smallest room in the building. So if you're having a mini anxiety attack, just looking at this photo, that's basically where I was on day 1. And at least I had a good view. Just kidding. It was of a parking lot and an HVAC unit on top of the building next to me. But anyways, time flew. To keep busy, had a little mini keyboard. I FaceTimed my cat and I went on a bunch of walks outside in the courtyard. And honestly, it was actually really nice to have computer work. This was like, it was good to keep busy. And yeah, the time actually went by pretty quick. So anyways, day 14 of the MIQ, or day 15, I think, we are ready to fly. Our whole team tested negative. This is all of us looking very excited. In Christchurch, New Zealand, they supply, the United States Antarctic Program supplies you with what's called extreme cold weather gear, ECW. So they give you everything you need to stay warm in Antarctica. So we got all of our gear and we got loaded up onto this New Zealand Air Force plane here, if you see this video. And this is all of us waiting in line to get on. Everyone has masks, of course, and we wore masks the whole way down. So then the next flight is down to McMurdo. So we fly from, we flew from New Zealand here, this red flight down to McMurdo, and that's another, I think 4 to 8 hour flight, depending on the plane. And so what, as the title of my talk and as the description suggested, this year, what we actually, we had our first year of carbon neutral travel. So as you can tell just from the last few slides, it takes a lot to get to Antarctica and a lot of planes, and planes emit a ton of greenhouse gases, which contribute to climate change. And so each person travels roughly 22,000 miles round trip. And we had 10 people. Normally we have 30 people. So let's just say our emissions are huge just to get down to the ice. And that has, you haven't even begun your research yet. So this year we decided to step up to the plate and offset our emissions. We offset 88.9 metric tons of CO2. And I'm going to circle back to this and we're going to talk more about kind of what that means and the details about carbon offsets in general in a few more slides. So, okay, so after that flight, we arrived in McMurdo Station. It's the largest base in Antarctica. It normally has 800 to 1,000 people. But because of COVID this past year, it was reduced season for the NSF, all the contractors and scientists. So we were lucky enough to be one of the science groups that was chosen by the NSF to go down, even though we were only at 1/3 of our normal number of deployers. And so there's only about 550 people on the station. And this is actually an image that I grabbed from the webcam today. So if you just Google McMurdo Station webcam, you can see a live photo of McMurdo, and also you can see what the temperatures. It's kind of fun to check in. When I'm feeling homesick for Antarctica, I'll do that every once in a while. Okay, so once we get to McMurdo, we spend about a week there. So we're in town gathering all of our gear, all of our science gear, our food, etc. Everything we need, all of our camping supplies, because we do camp out there. We sleep in tents. So once we get everything, all of our gear, it's usually around 2,000 pounds or more worth of gear. We take a helicopter from McMurdo Station right here all the way to Taylor Valley. It's about an hour. So you can see in this satellite image that it is, largely ice free. And so this is Taylor Valley, the one that I showed you a photo of earlier. So this is on the ground. We arrived. The wait was well worth it. I'll remind you at this point, this is about day 30 that, from when we all left our homes to actually arriving in the field, it's already been a month. So this year was very different from normal years. But it was well worth the wait because it's just about the most magical place on the earth. So you can see here, this is a frozen lake that I work on the lakes. There's a glacier here flowing into the valley. This is the McMurdo Sound over on that side. This is sort of a different view from what I showed you earlier. And so the McMurdo LTER, we have sort of different subgroups that have different specialties and focus on different disciplines. So we have a team that focuses on glaciers, and they're measuring how those are changing, taking mass balance measurements. We have a team that two teams that study the lakes. I'm on one of those teams that I focus on the electronics on the lakes to look at how the lakes are changing over time. We also have a group that studies the biology of the lakes. We have the stream team that they monitor the stream flow as well as taking measurements and collecting samples. We have a series of weather stations, which is also part of my responsibility and what I'll be talking about mostly today. And then lastly, we also have a soils team, and this is a really awesome video that my colleague David Robinson gave me from the BYU lab. This is a soil sample with the apex predators of the dry valleys. So the nematodes and tardigrades. The nematodes are the little worm guys, and then the little gummy bears are the tardigrades. And so that's what's living in the soils. And we also have algae living in the streams and the lakes, but there's no penguins or seals. And if there are, they're not in for a good trip because there's no food for them and they quickly starve. So anyways, so our team here is the physical limnology and meteorology team. We're all based out of Louisiana State. This is me in the middle with Michael and Katie, the two grad students that came down with us this year. The PI is Peter Doran, who did not deploy this year because it was such a long deployment, none of the PIs deployed. So we have 14 weather stations. You can see on this map, the yellow ones are the weather stations. We have a series of lake stations too. So this is one of our lake stations on the bottom where my cursor is, which I'm not going to talk about today. And then we have these weather stations that are collecting climate data. And the longest one is right here. This has been running for, I think, about 33 years. So we're officially in the climate cutoff of 30 years. So to look at the anatomy of a weather station, we have a bunch of different sensors on it. Each station is slightly different. And so my job as a technician is to make sure that these things keep running. So we have a lot of sensors on the station. We have the power supply, the solar panel and batteries. We have a data logger inside of this box that all of these sensors have wires that are coming off and then running along and then hooking up inside this box that are then collecting the data that we download. So they usually work, but sometimes they don't. And that's my job to go and fix it. So we have these enclosures. This is a peek inside of the enclosure, and I really hope that there's no electrical engineers on this call because I don't want you to judge our wiring panel, but I'm happy to report that we're actually upgrading all of these stations next year with new data loggers, and I get to wire them and be kind of a perfectionist about it in the next round. So anyways, that's what it looks like inside of the box. So and part of my job is fixing things that break. So in this case, Antarctica always is touted as the windiest, highest, driest, coldest continent. And the windiest part is part of my job security, I guess. So this is a photo of the Lake Bonny station this year that we visited. we showed up and the wind monitor was snapped off in about 30 feet away. So you can see the station right here where my cursor is, has this little solar panel on it. And this was found down valley, pretty chewed up. And of course, what do? We go and download the data and look at the wind data and see when did it happen. So plotted this up and you can see that the sensor snapped off in July of 2021 after an 86-mile-per-hour wind event. So that's a Category 1 hurricane. Yeah, you know, my job is downloading the data, but also fixing things. And it's a harsh continent, as they say. Okay, so that's kind of a little bit of overview about how we actually collect the weather data and our weather stations and studying the climate over time. But this talk's a little different from most talks that I give, because I'm going to talk now more about how we're trying to make our field work more sustainable and how we can reduce our carbon footprint. So, you know, there's a ton of resources that go into our camps, into our science, and it's all worth it, definitely. But, you know, there's ways that we can improve. And I think that as scientists that truly understand the crisis that we are in with the climate crisis, we're some of the people that understand it probably, you know, better than most. And so I think that it's really our duty to step up and walk the walk and try and be part of the solution. So before we start talking about carbon footprints, we should all realize what the definition is. So we're on the same page. So your carbon footprint is the amount of carbon dioxide and other carbon compounds emitted due to the consumption of fossil fuels by a particular person or group. So you can have an individual carbon footprint, you can have a team or a company carbon footprint. This is kind of an interesting little fun fact. The term carbon footprint was actually coined by BP, the oil company, back in 2005, which is really interesting because you hear a lot of people using it and you hear a lot of environmentalists use it. I mean, heck, it's in my title, right? But it was actually coined by BP. And it was strategically created as a marketing plan by fossil fuel companies to get people to start blaming themselves for climate change instead of industry. So they said, basically, we're going to make fossil fuel consumption a personal problem. So you need to look at your carbon footprint and you need to reduce your use of fossil fuels rather than perhaps changing systems that to stop using fossil fuels in the first place. But that's how it started. That's how the term came to be, and now it's widely used. And that's the little history lesson right there. So that being said, knowing your carbon footprint is useful. It's definitely useful to know where you're starting. So it allows you to take stock of your current actions, figure out what changes you can make, and really figure out what the biggest bang for your buck is with respect to what changes you can make in your life or your community or your job, etc. So this year, this was our team. This was on Polar Pride Day, all of us lined up. We started a sort of ragtag McMurdo LTER sustainability task force. And our goal of this group is to start looking at ways that we can address our carbon footprint and increase sustainability within our group, within our field work, within our labs. So there's 5 core things that we're trying to focus on and that I'm trying to look at first. So we're looking at our travel, getting to the ice, like we said, and like you saw, it takes a lot to get down to the ice. Getting around on the ice once we're there. Then also fuel usage for science. We're looking at lab waste, camp life, etc. And then also connecting and empowering students and researchers beyond. So travel. Getting to the ice, as you heard, this was our first year that the LTER offset our travel emissions. Very exciting. And I put a little star next to offset because it's a very big star that the next slide will go over. And if your ears are tingling that carbon offsets are, about them, then you'll know why we're going to go into depth about them. So like I said, each team member travels about 22,000 miles round trip to do fieldwork in Antarctica. And total, that's 88.9 metric tons of CO2 emitted just to get to Antarctica, which is the equivalent of driving 362,700-ish miles in a Subaru Outback. So that's a lot of miles just to get down there for flying. And that's just for 10 people. Like I said, normally we have 30 people. And to give you perspective, the USAP program deploys about 800 people-ish in the summer. So quite a bit of emissions related to travel. And so it cost us, though, it only cost us $1,500 to offset all 10 of our flights. And if you are not a polar scientist, I will tell you that $1,500 is a drop in the bucket of budgets for this kind of work, because everything is so expensive. And so this is really not much at all, about $150 per person. And so we paid for this ourselves. USAP, the United States Antarctic Program, pays for all of our flights and travel and everything once we're down there, but we paid for our offsets, and we weren't mandated by any organization or university. This was a totally grassroots effort within the LTER. And I was really excited once I pitched this idea that everyone was really on board with it and quickly stepped up, and the PIs sponsored their grad students, because I wanted to make sure that grad students who are already living on a tight budget weren't going to have to suffer from having to be guilted into paying an extra $150. So I'm really proud that all the PIs stepped up and all the grad students were sponsored. We're hoping that this is kind of the beginning of things, and we did this year as we were going down, but hoping that in the future this might be something that we can write into the grant that the NSF or funding agencies might be willing to pay for. Okay, so here's that star that I was talking about, and I'm going to say, if you do not remember anything from my talk at all except for this one thing, this is it: that carbon offsets are definitely not the #1 solution for everything. So I'm sorry to welcome you to Disappointment Valley, but we're here, and we can't just enter our credit card into the internet and make all of our dirty emissions go away. So carbon offsets are super tricky, and most of them actually fail to accomplish what they claim to do. And if you haven't heard the term greenwashing, it's basically when companies try to convince you that they're sustainable or doing the right thing when they're really not. It's kind of just for show. So greenwashing is everywhere with carbon offsets. And if you just go to Google and type in carbon offsets, or maybe click something on like a flight page that says, do you want to offset your flight? Your money is probably not actually going to fund carbon sequestration, meaning removing carbon from the atmosphere, which is what you would want to do if you're really trying to, I'm emitting this much, so therefore I want to pay money to try and sequester or remove that much from the atmosphere. Instead, it's likely just paying back investors who provided seed money to projects many years ago. So if you're buying a carbon offset through something that's claiming to do renewable energy work, that wind farm or that solar farm was probably already there, and you're simply just paying money back to the investors. Or if it's something with forestry, usually it's paying people not to cut down trees, or to pay investors who planted those trees a long time ago. So you can't just basically say, oh, well, I can fly as much as I want and I can do everything in business as usual. I'm just going to go in, type in my carbon, figure out my carbon footprint, offset it, bing, I'm done. If you're going through traditional carbon offsets, it's really not the solution. So that brings me to, I know that you're probably like, wait, what, Krista? But you just said that you offset your emissions, and here you are telling us that carbon offsets, suck and aren't the solution, which is true. But we found this program called Onora. And so instead of purchasing traditional carbon offsets, we donated our money to Onora. And it's a program that provides funding to projects that remove carbon dioxide from the atmosphere. So these are some of the projects that they have gone out and vetted and actually fund. So the Ocean Foundation, the Community Afforestation Project, the Future Forest Company. So they're funding these projects that are actually sequestering carbon. So it's different from traditional carbon offsets because the money funds new carbon sequestration projects that are actively repairing natural ecosystems. And this is where, as a scientist, was very important to me. They are transparently measuring the amount of carbon being removed. So they're actually verifying that these projects are removing that amount of carbon. So when we say that we removed 88.9 or whatnot tons of CO2, they're donating to groups that are actually verifying their amount. And Onora also funds high school fellowships, focusing on empowering youth to take action on climate. And it's just overall a really good group. And I highly recommend that you check them out. They also have a carbon calculator on there if you want to check out your carbon footprint. Okay, so that is how we got to be claim carbon neutrality for our actual transportation down to the ice, but it doesn't stop there, obviously. So once we're down on the ice, we still use a ton of fuel. And really the first line of defense with reducing your emissions should be that, reducing the emissions. You're not trying to, just offset things or whatnot. If there's any way that we can just not burn the fuel in the first place, that's definitely the best method. So one way that we can do that with helicopters, which is our primary mode of transportation out there, is to increase efficiency. So that's how we get around to the different weather stations. If you remember that map, they were all pretty spread out, tens of kilometers between each station. And so we can't necessarily hike there with our ladder and all, 100 pounds of equipment. So the helicopters fly us around. And this year they did a really good job of combining flights and increasing efficiency. So by combining flights and reducing personnel if possible, just means less flights in general, which means less fuel burned. And this year, the LTR only flew 86 hours out of our 127 planned hours, which is, I think, a little less than 70%. And so that's great. We didn't use up all of our hours. And ideally, moving forward, we can continue doing that. And I'll note that that was largely due to the humongous effort by the helicopter operations manager down on the ice this year, Haley. She did an incredible job of just figuring out efficiencies, which was actually largely due to COVID, but this might be one of those situations that we can take something from COVID that we learned and maybe continue forward with it. Just like there's probably some things that we've all realized in life that we're doing differently now. So, and for what we can't reduce, because there's going to be no way that we can not fly to Antarctica, and then we also have to use helicopters to get around. So for those two situations, that's where I would say that offsetting by donating to groups that are actually sequestering carbon is probably your best bet. And then the other way we get around is ATV travel. So I was looking for a photo of a helicopter, and I was looking for a photo of our ATV, and I found a photo with both in it. So here's a picture of the helicopter slinging a ATV around. When we use it, it's not in the air, but this is how they transport the helicopters between camps. And if it needs to get maintenance, it goes back to town. So we drive these ATVs around the lake ice when we're working out on the lakes. So in the future, reducing ATV travel if we can, but really what we would hope for, and that we've been talking with folks in McMurdo about, is going with new ATVs, ideally electric ones. That would be awesome if we could totally reduce the fuel that we need to use down to zero for the ATVs, which has also the co-benefit of not burning fossil fuels, but also we won't be, there'll be less spills, because when you're handling fuel, it's inevitable that you're going to spill. And I'll note at this point too that all of our camps are powered by solar. So we have these huge solar arrays with batteries, and a majority of the camp is powered by solar. The heaters are still diesel or propane, but we're moving towards an electric camp, and we do have backup generators. So we could charge, big ticket items and batteries. So, okay, so fuel usage for science. So now we've gone over, looking at our travel, and we're going to start focusing on that. But now we also want to look at what we can do for our science. So this is my colleague, Michael Stone, working hard on a looks like a buoy covered in slime or something. And he's next to our lake ice melting equipment. So this is one of our fuel stashes. We have 55-gallon drums full of diesel or gasoline. And we have a generator here and what's called a hot seat. It's an ice melter. And these things take up a ton of fuel. And so one thing that we've implemented over the last few years is just switching to kind of getting smarter about how we melt the lake ice by switching to an every other year cycle of melting out the lake instruments. So just like how the weather stations, the sensors needed to be recalibrated every 2 years or so do the lake stations. But every time we melt out the lake stations, we swap all of the sensors. That way we don't have to come back next year and swap one and then the next year swap another. We just swap all the sensors at the same time, and that way it can stay in the lake for 2 years. And that saves 450 gallons of fuel every year. And also, not to mention, saves a ton of time on our part, and also all of the resources that it takes to get all that equipment out to the lake. So it's way more than 450 gallons of fuel saved right there just by sort of working smarter. And next steps, we want to conduct an audit of past fuel usage and identify patterns and ways to reduce. So we want to look at how much fuel are we using year to year, how much has it changed, has there been anything to make it go higher or lower, and then try and go from there and figure out ways that we can reduce our fuel usage. Another really awesome effort this year was to reduce lab waste. So this is my colleague Emily right here, and Emily and Kathy both did an excellent job leading the charge on this, reducing lab waste. So we just simply by talking to people in McMurdo found out that we have these things called carboys, which are these sort of plastic, if you can see my cursor, plastic containers that hold liquid up there. And so typically in what they do or what they do to get rid of their HCl waste is they will rinse a vial or something and then dump their HCl waste into a container that then has to, get transported and tagged as hazardous waste. But what we didn't realize is that the carboys were then being emptied by HazWaste. So, Emily would send it off to hazardous waste. Then the hazardous waste folks in McMurdo would then take that and dump the HCl waste into a larger drum and ship that back to the United States. And then they would also take that empty carboy, put that into a cardboard box with a bunch of other empty bunch of them, and then ship that back to the United States and have that also be disposed as hazardous waste. So this was something we didn't actually even realize was happening, but Emily found this out. And so Emily realized that we can keep reusing those HCl waste carboys. So this was kind of an idea of Emily just getting creative, thinking about ways that, and talking to people, talking to someone in hazardous waste and finding out that we can just reuse those. And that's great because then they don't have to send it back. So it's way cheaper for the NSF not having to deal with hazardous waste. And also it saves that perfectly fine carboy and we can use it indefinitely. We're also working on reusing sample containers and pH vials, and the star there is because of course we are doing science. And so we don't want any of these sustainability efforts to get in the way of data quality. And so Emily actually did a few experiments this year comparing if, whether or not it was possible to reuse some sample containers and vials. And she determined that some of them you could, some of them you couldn't. And that was great. So we got change through that, and we're putting that into our standard operating procedures. And also recycling tinfoil. So I really hate that we don't have a photo of this, but if you clean tinfoil that doesn't have any chemicals or anything gross on it, and this goes for your day-to-day life too, you can't recycle tinfoil in little tiny pieces. So if you have something to cover like a Tupperware or something like that, if it's clean, if it's too small, they can't recycle it. But if you have a bunch of clean, dry tinfoil, you can ball it up over time and make this kind of massive tinfoil ball. And then you can recycle that as aluminum. So they were doing that. So thank you to everyone for doing that. And that's me pretending to be a chemist. I'm not, but they told me I didn't need to wear the lab coat, but I insisted. Okay. So here's one of the last things that we are focusing on, which is addressing camp life. So this is our super glamorous hut this is actually my favorite camp. This is Lake Bonny. And so this is what our hut looks like. This is where we live and eat and, decompress after a long day. It's where we cook our food. So we have a hand washing station over here. We have our food pantry. We have a kitchen with a refrigerator and a stove. And then we have a heater over here that also doubles as a water melter. So we have a cauldron that we put lake ice in, and then that melts and we can use this little spigot to get drinking water or cooking or whatnot. So the ways that we are thinking about, improving our camp life too is, so for hand washing, conserving water. Water takes a lot of energy to get, and then also all the water that we create for gray water, we have to ship off continent. So conserving water from the get-go. This year we started doing this thing where I invited my team members to bring down cloth hand towels instead of paper towels. So, if you wash your hand 10 times a day, it's really sucks to go outside with wet hands when it's like very cold outside. So we had hand towels that, everyone had their own pretty colorful hand towel. So everyone kept track of their own, which really reduced paper towel usage. For food, reducing food waste, everyone's already pretty good about that, because all the food waste that we generate in the field has to be shipped off continent. And also food waste is a huge contributor to greenhouse gas emissions. It emits methane in the landfill, and so it's actually a very potent greenhouse gas. So if that's one thing that all the listeners can take home and implement in their own lives, is reducing food waste and also eating more plant-based options. About half our team was vegetarian this year, so it was really awesome. We, mostly eating vegetarian, maybe not super strict, but so half of our meals are vegetarian, which was really cool. This was the first year that that happened. And eating more plant-based food, you don't even need to be fully vegetarian, but eating more plant-based options is a great way to reduce your carbon footprint, especially beef. Cutting out beef. So then in the kitchen, one thing that we're pushing for is all electric appliances. So this is an electric refrigerator, but the stove is still propane. This is something that you can do in your own life too, is that electric appliances are definitely a great way to reduce your home's emissions, especially heating and cooling. So your HVAC systems back at home, replacing those with an electric heat pump is a wonderful way to cut down your emissions drastically. And then same with converting your stove to electric. So one day, that's out of our control. That's kind of in NSF's court, but we keep asking for it, keep pushing for it. It's also a health and safety issues that electric stoves are just simply a lot safer, and also they don't leak any harmful gases. So, and then this is us, our hot water, our heater is diesel, which speaking of not being good for health, this is probably the worst in the hut. But anyways, we hope one day it'll be electric. And this is our teammate in our solar array out at the Bonny camp, that we have these huge, 300-watt solar panels. We have a huge array of them. So more solar, the better. Okay, and then lastly, the goal of the task force is to connect and empower people. So I really started this because I think there was a lot of people that I was having conversations with in Antarctica, scientists as well as just the people working down there, where everyone kind of was feeling a little helpless and not really knowing what they can do. And everyone down there obviously really cares about climate change and wants to make a difference. And so I thought that there is definitely a need for us to start talking about these things and having accountability, because we need all sectors to talk about climate change and to tackle it. And so that includes scientists for walking the walk, for sure. So, the task force, we want to empower everyone to make changes in their labs, communities, and personal lives. And this is my dream, my pipe dream, is to have a connection with other polar researchers, or even just any field scientists, and to share ideas about what are ways that you've decarbonized your research, what are tricks to reduce waste in the field, or maybe good green lab options. I know that a lot of universities have some green lab programs and stuff. So we're gonna, this is a brand new task force. It's only about, less than 6 months old. very much in the beginning stages. So we want to reach out and start connecting, maybe even within the broader LTR. And the last thing that I kind of want to say with the connecting and empowering people is that I think a lot of people forget that we still have time with respect to climate change. We have this next decade is really the most important decade in human history. And so if there's ever a time to really push for something and to make change and to disrupt the system that currently is really not working, this is it. And I think that's a message that a lot of people need to hear, that collectively we can make a difference. And it is proven that there are solutions out there to basically reduce the impact that we're going to be feeling from climate change for the next couple hundred or 1,000 years. So I'll leave you with sort of a little few links for you to start your climate journey. You can assess your own carbon footprint if you're not familiar with ways to make your life more green. Some ideas are going electric, so converting your house and your car, and also the way that your energy is actually provided to you, pushing for electric renewable energies. Eating more plants, so reducing your meat intake and eating locally, and also reducing your air travel. Like I said, that's a huge way that we have emissions. So, if you can take a conference over Zoom, that's definitely better for your carbon footprint. And there's tons of carbon footprint calculators out there. Like I said, Onora has one. There's a ton all over the internet. A lot of them, they'll give you probably slightly different answers, but they kind of have the big ticket things that you can change in your life. Another project that I really, really encourage you to look at is Project Drawdown. It's drawdown.org. It has a resource for climate solutions. So if you're just like, I don't even know where to start, or what are we supposed to do as a society? This is such a big problem. Drawdown has a list of climate solutions that they actually quantify how much each solution would reduce in emissions globally. So it's a really cool, just sort of high level, and food waste is spoiler alert in the top 3 or 5, I think. So there's a lot of things that you can do in your own home, and a lot of things that might surprise you. And Drawdown has this really awesome resource called Climate Solutions at Work. And it's a how-to guide for employees looking to make every job a climate job. So if you are inspired by this talk, if you're thinking, well, heck, if Krista's doing it, if she's going and making a fuss at within her research group to try and step up and reduce our emissions and tackle climate change, then you can too. And check out this guide. This is an incredible resource. So definitely go and check them out. Look at your city's climate action plan. Like Andre mentioned, I'm involved in my own local climate action task force. And you just show up and volunteer. It's usually just like once a month, but even if you don't want to get involved to that level, just simply reading your city's climate action plan and they constantly want feedback. Trust me, they want to hear your thoughts. And so you can be a voice in your own local community. And I think that actually focusing on local solutions is a way to empower you and make it a little more manageable than trying to tackle, the whole global solution or global problems. And then also finding your strengths is another option. Check out this All We Can Save project. They have this little Venn diagram to help you figure out what you should do about climate based on what brings you joy, what you're good at, and what work that needs to be done. So that's it for now. Thank you so much to CSU for inviting me, and the National Science Foundation, all the folks that make our fieldwork possible, and all my fellow Reduce Season teammates this year. If any of this sounds interesting to you and you want to reach out to me, definitely shoot me an email. I want to start something here. So the more the merrier, and I'd love to hear your thoughts and share ideas. So that's all. Thanks, everyone.
Thanks, Krista. Thanks for not only inspiring us, but actually providing a resource that everybody can check and take action, right? Because that's what we need to do at this point.
Yeah.
So thank you a lot. We do have some questions here that I want to share with you.
Okay.
The first being, and I'm actually going to combine 2 questions here. So when did you start thinking about the carbon impacts of your field work, and what got you interested in taking action on that? But also, if you can add to that some advice to college students who want to start doing work in Antarctica.
So sorry, the first question was, I have a terrible memory.
Oh,
The first question was,
okay,
when did
so I'm not
when
gonna
did I start?
I'm not gonna combine questions anymore.
Okay.
So the first one was how did you start thinking about this carbon impacts of your field work? How did you get interested in that?
Yeah. So, I mean, basically everyone that the first year that you go down, it's, I think most people realize pretty quickly, like, wow, this takes a lot for me to get down here. And my climate activism, it really ramped up the longer that I've been studying and doing research in the climate sphere. Because like I said, the more you know, the more you realize kind of the stakes that what's at stake right now, with respect to, tipping points and just ecosystems changing potentially forever. How can you not get involved? That's kind of I really found a lot of power in trying to act on it. So, but with respect to actually trying to do something about it, this was really, I mean, I had been trying to do things in my own life, like, I've gone vegetarian, I work from home, I don't fly much, all of those sorts of things. I bike, but this was the first year that I'm really pushing my workplace to try and address it. So pretty recently, and I think it's never too late. I think everyone needs to start, and if you're going to start, this is definitely the time.
Nice. And this next question speaks by the inspiration that people are getting from your talk. So what type of advice would you give to college students or anybody at the early stages of their career who want to start working in Antarctica like you did?
Yeah. So I actually got started being involved in Antarctic research as an undergrad. And I simply went to a professor that I had taken his class, Slavik Tolachik's his name, and I took his course. I really liked it, found him very inspiring. He actually studied Antarctica, but I just went to him and kind of asked him, like, hey, what do you do with a geology degree? I was like 19 or 20 years old, had no idea what I wanted to do. And he said, gave me some tips. And then he said, well, do you want to start working in my research lab? And I had no prior experience working in Antarctica. I'm from Los Angeles. I don't even like the cold. And he took a chance on me. He said, yeah, come and work for my lab. So I'd say reach out to, if you see a professor at your university or, some professor at a different institution, reach out, ask to do some undergraduate research. That's definitely the best way in. And you can kind of figure out what you like and what you don't like. And if you don't like something right away, like, you don't have to be locked into it. Like I started studying glacial seismology. So looking at ice quakes in Western Antarctica. And what I found out is that I really do not like seismology, but I love Antarctica. So it was kind of an interesting way into it. And then I, changed what I was doing. So yeah, I'd say undergraduate research lab. And then if you want to go to grad school, that's a really great way to actually deploy. And if you're an undergrad, look at places that have REUs, research experience for undergrads. I think that's through NSF, and that's a really great way to get funded to do research and maybe go to Antarctica.
Yeah, definitely. So there is a question from Amy here, which is more on daily life in Antarctica, and she's asking about the drinking water.
Yeah.
You mentioned at some point that you treat the ice melt before you drink it. Is that right?
Yeah, so we do have filters. It's not here. You can't see it, but behind this hand washing station is actually where we have our drinking water. And maybe I'll leave this slide up so you guys can jot down some notes. But we have filters that we put our drinking water through, but the water is so clean that honestly you probably don't need to filter the water because we're not discharging any water into the lakes. So as long as you're, kind of staying away from the camp where we're driving with ATV, the water's actually really clean. And another kind of fun fact about just how clean it is down there, I mean, you could drink the water, there's no giardia or, you don't need to be worried about that stuff. But the air is so clean down there. There's so few pollutants in the air that even when it's like minus 30 degrees Celsius out, you can breathe out as long as you're not around any buildings or anything like that. and you can't even see your breath because there's not enough dust particles or, particles in the air for it to nucleate on, for it to condensate on. But then the second you go next to a generator or an ATV or something like that and you breathe out, you can see your breath instantly. So it really just shows how clean it is down there, really.
That's interesting, very interesting. There's a question from Dennis here about, so what do your temperature data say about the changing climate in Antarctica? Do they show unequivocal warming or are there other trends?
Yeah, so I actually have a slide on that. So the trends in the dry valleys, it's not, the way that Antarctica is warming is it's not warming at the same rate everywhere. So what's happening in the dry valleys is, this is from a paper from 2020, Obrick et al. And what we've seen from our weather data from the stations that I was showing you guys about, that there was actually a cooling trend in the dry valleys, specifically in the dry valleys, from the 80s through 2006. And then after that, it was sort of a change point. And now we've entered this period, which is a warmer period. There's warmer temperatures, but there's no clear trend. So we have entered a kind of a new era of climate in the dry valleys in the last few decades, but it's not warming, say, as fast as, the peninsula, the Antarctic Peninsula, which is warming, really fast. So it just reminds you that, there are nuances to climate change. You can't say that everything's warming at the same rate. For instance, the Arctic is warming, super rapidly, but then there's places in Antarctica like, the valleys or East Antarctica, which are maybe warming a little less slow or a little less fast. Yeah.
Right. Cool. Then there is a request here for you. If you could go back to the slide where you show the organization that you guys end up using for offset and sequester carbon. Yeah. So you all can take note of that if you are interested.
Yeah. Yeah. And I would also recommend, if you want to reach out and ask questions, the director, Adam, he's great. I'm sure you can email him and, just contact on the website and he'll get back to you pretty quickly. I think he's actually even on this call right now. So he's obviously interested and reach out to him.
Cool. And I have a question about the offset part of your talk. You mentioned that the dry valleys are one of the windiest places on Earth, but I didn't see you mentioning wind electricity being used as a mean to reduce food, gasoline or diesel using in Antarctica. So are there plans on that regard, or is just that it's the equipment itself could be part of the environmental impacts that you want to avoid?
Yeah. Okay. I'm just looking through the panelists, and I wish that we could unmute because there's someone on the call, my advisor, Peter Doran, that he would be able to answer this. There was a wind turbine at Lake Frixel Camp, and it was removed. And I don't know if they just decided that it wasn't, robust enough or not producing enough energy or power. I'm not really sure. There are wind turbines in McMurdo that are that the New Zealand base actually uses. So they get almost all of their energy from just wind and solar. And also New Zealand, Antarctic New Zealand is awesome because they are, I'll go back to this slide too. Antarctic New Zealand is awesome because they're actually trying to not use fossil fuels in the next few years for their field camps. They're trying to be totally renewable. And they're doing a station rebuild too, that they are going fully renewable. So, and wind is a huge part of their solution. So I'm not sure why the remote dry valleys camps. Okay, Peter, I see is saying high winds made it difficult, but it could be done. So I think it's just cost effectiveness is what I would guess. But and also when we are there, so we're only there, I guess I kind of glossed over this, but we're only there during the summer, right? When it's the austral summer, so that's October through February, when it's 24 hours of daylight. So solar is a really awesome resource. In the winter, we're not there. So it's I think that's probably why, is because it's, solar is so effective, but, and I don't know if they would just let the wind turbines, I guess, keep going in the winter. But Yeah.
Awesome. Well, we run out of time. It feels like we could be talking about these things for a while, but Krista, thank you very much for being here tonight. This was an amazing talk, and I think you touched on some very important points about encouraging people to take action on their own climate impacts. So thank you all for being here with us. As I said, this is going to be available. The recording of this is going to be available at the YouTube channel for the Poudre River School Library, Poudre Public Library. Probably tomorrow or the day after tomorrow. So some of you can share the link for that with your colleagues who couldn't be here tonight. So thank you all. Thank you, Krista.
Yeah,
and
thank
we'll
you
see
so
you
much.
next time.
Have a great night, everyone.
Bye-bye.
Bye.